Alright, in this video we are going to look at solving a few examples of quadratic equations using the square root method. Alright, in this first question, our first step is going to be to try to get the x squared alone. And the best way to do this is to use your equation solving skills. So think of this kind of like a two-step equation. Our first step would be to take the inverse of this negative 10, which would be to add 10 to both sides. Okay, they're gonna cancel each other out on the left side of my equation. So we'll get negative 3x squared is equal to, and then negative 46 plus 10 will become negative 36. Okay, from there, now we need to take the inverse of this negative 3, the coefficient, and the inverse of that is going to be to divide. So we'll divide both sides by negative 3. They'll divide each other away on the left side, so we're just left with x squared alone. And then negative 36 divided by negative 3 would be 12, positive 12. And that's step 1. Notice here now we have the x squared by itself. Now we can deal with taking the inverse operation to get rid of this square power. And that's when we take the square root of both sides. The square root and the square are inverses of each other and will cancel each other out. But when we do that, we have to ask ourselves, what multiplies by itself to equal 12, since that's the number we're taking the square root of, and that's where we come up with there's two possibilities, the positive version of the answer and the negative. So we have to use the plus and minus symbol to express our answer. So here we get x is equal to plus and minus 12. Now, if I try to take the square root of 12, I can't do that because it is not a perfect square number, but we can simplify the radical. And that's where we go to making our factor tree for this. So off to the side here in orange, I'm going to do the square root of 12. And I'm going to look for my prime numbers. I'm going to create a factor tree. I think I have 4 times 3. 3 is prime, so I can't go any further, but 4 is not. I can go 2 times 2. So that means my prime prisoners are 2, 2, and 3. And in Radical Gel, we have to pair up our buddies. So we'll do that by circling the pair of 2's and underlining the 3. And remember, simplifying the radical, we get the pair of 2's break out of the house and become a 2 on the outside. And the 3 has to stay behind because it doesn't have a partner. So if I wanted to simplify my answer entirely, instead of x equals plus or minus 12, x is going to be equal to plus and minus 2 square root 3. And then my fourth step is to get x alone. But notice in this problem, x is already alone, so for this problem, we're done. That's the answer. Okay. In our second example, notice here that we're not just looking to get x squared alone, because we have x plus 3 that's all being raised to that power. So in this case, x squared can also mean x minus h squared. Either one of those. Okay, so that's the term that we want to get by itself. We're going to do the same thing we did before where we tried to use our equation skills. So I'm going to start with this minus 3. I'm going to do the inverse of that, which is to add 3. They're going to cancel each other right here. We're going to get 3 times parenthesis x plus 3 squared is equal to 72. Now be careful with this, because we have a coefficient of 3 in front of the parentheses. We can't distribute it because there's an exponent involved. So we have to divide it, just like we did before. So we're going to divide both sides of this equation by that 3. They'll cancel each other on the left side. And 72 divided by 3 is 24. So we get x plus 3 squared is equal to 24. That's step 1. Now we can do the square root step. This is where we take the square root of both sides. The radical and the exponent will cancel each other out. And now we're just left with x plus 3 on the left side. And we have plus and minus the square root of 24. Again, just like the first problem, I can't take the square root of 24, so I need to try to simplify it. So I'm going to think of numbers that multiply to 24. First thing that came to my mind is 6 and 4. 6 breaks down to 3 times 2, and 4 breaks down to 2 times 2. Okay, radical gel, I want to pair up my prime partners and underline my singletons that don't partner up. So when we simplify this one, the pair of 2's breaks out as a single 2, and then the 3 and the 2 that didn't have partners have to go back inside, but when we put them back in, we want to remultiply them back together. So 3 times 2 is going to be 6. So when we rewrite this problem, we're going to get x plus 3 is equal to plus and minus 2 root 6. Okay, that's step 3 right there. The next step is to get x alone. And notice in this problem, unlike the previous problem, x isn't alone. I have this x plus 3. I need to get rid of the plus 3. Now, if the radical simplified, like the square root of 25 would be 5, then it's going to look a little different than what we're going to do here. For here, we're just going to try to subtract 3. Okay, now we get x is equal to, and then I have a negative 3 here, and I have a 2 square root 6. Because the 3 doesn't have a square root 6 on that, it's not going to be considered a like term. So when I write this, I want to keep these separated. So I want to do negative 3 plus or minus 2 times the square root of 6. And that's the answer. Okay. My last example is going to be similar to the first one, or the previous one that we just did. We're going to start with getting the x squared alone, just like before. I'm going to start with the inverse of this 10. I'm going to add 10 to both sides. 8 parenthesis x minus 7 squared is equal to 72. And then I'm going to try to divide by 8. And we get parenthesis x minus 7 squared is equal to 9. That's step 1. Step 2 is to take the square root. That's going to leave me with x minus 7. And then I'm going to take the square root of 9. Now, unlike example 2, this one, the square root of 9, is a nice clean number. It's 3, so my answer is going to be plus or minus 3. And that's going to be step 2. Now, I've also don't have a situation here where I need to simplify radical, so I get to skip step 3. And because of that, getting x alone, I don't want to just go straight to adding 7 to both sides. Because I have 3 here and not some 3 with a radical, I want to create 2 separate equations here. One where I have x minus 7 is equal to positive 3, and one where x minus 7 is equal to negative 3. Because the 7 and the 3 are like terms, when I add 7 to both sides, I am able to simplify this and combine them together. That's the reason that we have to separate into 2 separate equations. In example 2, I wasn't able to do that, so I can leave it the way it was. Alright, if I start with 3 and I add 7, I get x is equal to 10 as a possible solution. And then I get negative 3 plus 7 is going to be 4 for my other solution. And that's 3 examples of solving quadratics using the square root method.